everybody agree you can make cosine squared theta equal sine squared theta? Then you could take the square root. And you would get cosine theta equals sine theta, but you got to remember you took the square root, so they could be what? And then, where are they equal or have the positive or negative of each other? You'd get what? The exact same four solutions. So Mr. Beckham, yes, you can do it that way, but what had you better do before you decide to take those square roots? Yeah, you don't set up where we take the square root, you just get the square root of each term. If you take the square root over here, you can't just do the square root of each term. All right? So that is an option. Okay. Now, keep working, Evans. Don't take a break yet, because these kids might have to work tomorrow. You work today. All right. Because I want to get, I'm going to have y'all ready to start working some problems. Now, I want to work a special case problem here. And I'm probably going to work it and, well, let me work two little special cases. Here we go. This one's not that difficult. I just got to show you what happened. Tangent squared x plus tangent x minus 2 equals 0. All right. Does everybody agree we're about to factor? Does everybody see a trinomial? Yeah, you're about to factor. You're going to do tangent x, and then we're going to put a 2 here, 1 here. And that's going to be a positive 2, negative 1. And you're going to double check my factoring. Yep, that's it. So you're going to tangent x equals 1. I'm skipping a step there because I'm not putting where I made it equals 0. Y'all have seen that enough. And I get tangent x equals negative 2. All right. Now, this one is on your unit circle. Tangent x equals 1. So what do you get? You get what? Pi over 4. And, no, tangent x equals, yeah, pi over 4 and what else? Pi over 4 pi. Pi over 4 pi. Now, this one's not on the circle, is it? By this point, you're supposed to know your circle well enough, or you look and you realize that's not on the circle, is it? Okay. Uh-oh, not on circle. Question mark. This is where you would say x is equal to the arc tangent of negative 2. And if you were allowed to use calculators, you could punch out in a calculator and get a decimal. We're not doing that, folks. We just leave it like that. And I'll go ahead and tell you, everything on your test will be on the unit circle. I'm just showing you this as an example of what to do if you're not on the what? Unit circle. But everything I'm going to give you to work is going to be on the unit circle. Everything I'm going to put on test is going to be on the unit circle because I don't want you to have to do what? Punch a calculator. And we'll look at these a little bit later, but for right now, everything I'm going to put on there is going to be on the unit circle. So just, you know, hey, Mr. Evans, what happens if it's not on the unit circle? I just showed you. All right. This problem is the example that this would be a difficult problem if somebody never showed you what I'm going to do here. This was the hardest problem in her book. There's only a couple of them, I think, in the assignment. And it doesn't look hard, but here we go. The serious equation example. All right, here we go. Tangent x plus the square root of 3 equals secant x. Folks, I look at that problem and I would love to isolate the trig function. But when I look at it, I try to isolate the trig function, I realize I can't. Because I got a tangent x and a what? Secant x. So, I'm looking at it, and am I better with sine and cosine trig identities than I am tangent? Yeah. So once I look at that one, if I can't isolate it, and I can't factor it, my thought is to change to sines and cosines. Yeah, and that usually works. So we're going to do it. If all else fails, just change it to sines and cosines. And then I do get kind of excited because I could subtract 1 over cosine and get it on this side, couldn't I? Right? So I can do this. I can get sine x over cosine x minus 1 over cosine x equals negative square root of 3. And that kind of gets me excited there because, hey, I even got a common denominator. Problem is, have I made it any easier to isolate any of that? No. Still not very pretty. That doesn't look too good to me. I'm going to change the order of that. I'm going to make it 1 minus sine x over cosine x equals square root of 3. What did I do? I just multiplied both sides by what? Negative 1. Why do you think I did that? Is anybody... yeah, if I had 1 minus... yeah, if I had 1 minus sine squared... okay, 1 minus sine squared x factors into 1 plus sine x 1 minus sine x, right? Everybody see how it factors like that? What I keep thinking I want to do is multiply this by 1 plus sine x and multiply this by what? 1 plus sine x. And that way I'd get cosine squared, because does everybody agree that's cosine squared? So in other words, if I take the 1 minus sine x I have, I'll multiply here, I'll get that, and I'll just get cosine squared. Well, I'm going to do that. 1 minus sine x over cosine x, and I'm going to multiply this side by 1 plus cosine x. I'm sorry, 1 plus sine x. I'm trying to think ahead here. And 1 plus sine x equals square root of 3. So I multiply those together, I get 1 minus sine squared, and 1 minus sine squared is what? Cosine squared. And I've already explained that over there, so I'm going to skip down, I'm going to get cosine squared x, cosine x, 1 plus sine x equals square root of 3. Well, oh, check it out. Cosine squared over cosine makes me feel good, because what can I do with that? I can divide one of those out, right? Cosine squared over cosine. Be like an x squared over an x. Is that okay? Cool? Yeah. So I get cosine x over 1 plus sine x equals square root of 3. And then I get all excited, and I realize now I've just got cosine x equals 1 square root of 3 times 1 plus sine x. Didn't do a very good job of isolating it, did I? It didn't work very nice, did it? Didn't do what I wanted it to do. Yeah, Mr. Evans, that's a bad day right there. But normally, if you do this, it works out to something that's easy to work. But notice I've done 1, 2, 3, 4, 5, 6, 7, 8 steps, and I'm not getting anywhere, right? Okay? Normally, this is the thing to do. Change it to sines and cosines. Everybody hearing that? If you have to do what I'm about to do, and you're trying to do it a whole lot, you're messing up, because normally what I just did works. Change to sines and cosines. All right, but it didn't work. So, you can throw this at me if you get tired of me leaving it on your desk. I would have never thought of this, probably even teaching this, except I saw this problem in her textbook and had to, use my brain. And she had an example. She has this example in her book, and she points out what happens when you can't do, when that doesn't work. This is a special case. This is one of the trig identities that I gave you. It's based on the mother identity. Okay? Right there. And what our friend says you should do is that you should square both sides of this equation. And the reason you want to square both sides of this equation is it will give you a chance to use that identity. It'll help you because it'll make an identity that you use. If you'll notice, out of all the identities that you have, you don't have one for just tangent x or just secant x. But you do have one for tangent squared plus what? Secant squared, right? Or tangent squared plus 1 equals secant squared. Now, when you do square this one, you have to think this. You don't just square each term. It's a binomial, so you have to write it out twice and do what? Use that F word. Okay? But on the other side, you do just get what? Secant squared x. When you multiply this out, you get tangent squared x plus 2 square roots of 3 tangent x plus 3 equals secant squared x. I used the F word there. And I even wrote in a step to help you remember that from Algebra 1. Then I'm going to show you the next step. Make it equal 0, but notice I didn't put the secant squared on the very end. I put it here in the middle. Because what is tangent squared minus secant squared equal? Look over there. What would tangent squared minus secant squared equal? Is that cool? It's -1, right? So if that equals -1, is everyone okay that I can put that -1 with the 3 over there?
Please send Peter Williams to the counseling office.
Okay, give him about 5 minutes and I'll send him. Is that okay?
Okay, thank you.
All right. Now, so that equals -1. Oh, look, we got just tangent x and we can isolate it by itself. And tangent x equals -1 over the square root of 3. And once I get -1 over the square root of 3, I can simply do what? Look on my unit circle. Folks, that's one of the hardest problems I've ever seen as far as solving trig, because usually if you turn them into sines and cosines, it works. Okay? And this is a little special case where you have these tangents and secants, and you're trying to isolate them. If you can't isolate it, you've tried the sines and cosines, you can't get it to work out, square both sides so that you can use that trig identity. And then you see how you're just left with what? Tangent x. To be honest, on the other one, did I have a situation where I had like 1 minus cosine x over sine or something like that when I showed you how to work it and it didn't work? Did you write down all the notes when I showed you how to work it and it didn't work, or were you smart enough to not write all that down? When I was showing you the long way and it never worked out, did you write all that down?
I wrote a little bit.
Yeah, and then you realize, if you would have squared it at the point, if you'd have squared it where you had 1 minus sine x over cosine x equals square root of 3, and squared it there and pulled it out, I think that one would have given you a workable equation too. Okay? I think it would have. But anyway, this is a little trick that's in her textbook for very special cases. If you're trying to do this on every problem, it's wrong. Okay? You try other things first. Now, in her textbook, I'm only picking out the ones that will give you solutions that are on the unit circle. And if you look in the, if you look in Canvas, I've already got the 6.2 Lial problems in the book. I've already got them in the Canvas, waiting on you. All right, got pictures of it, got the problem numbers and all that, waiting. I would strongly suggest not that many problems. It's like 11 through 34. But it's all of them. Tomorrow and the rest of today, you better put a big effort into that. Because on Wednesday, I'm going to lecture on 6.3, which is still solving equations. And then on Monday of next week, I'm going to lecture on solving equations where they're involved like sine 2x, cosine 3x, and a whole section of those. Okay, and I will do the Sisson book starting Monday, and then a week from Monday, 2 weeks from today, you're going to take the test. You're going to decide who gets an A in here and who doesn't. Right there. That's a test that will eliminate people from getting A's in here. I know it will. Some people will say, oh, but Mr. Evans, I can use my unit circle, so do I really need to study? Yes, because if you hadn't worked the equation, you're not going to do well. Also, you've got to turn in a packet that has every assigned problem in this unit worked. Yes, you're going to staple it together. You're going to walk through the door on test day, dropping it in a box right here. All right? And then while you're taking the test, I'm going to look through them and pick out a few that you didn't do and give you a 0. All right? Or whatever. But seriously, we want these worked. We want it. And I'm going to give you your booklets back to carry with you because this is the biggie.